Hello, and welcome to this Raise3D Technologies webinar. Now I would like to introduce today's presenters. With us today, we have Taylor Kirk. Taylor is in the technical sales with Raise3D. Also joining us today is Ed Thomas. Ed is the BD manager of 3DP at Henkel LOCTITE. And we also have Ethan Fish. Ethan is the product designer with HellermannTyton. To read more about any of the presenters today, just go ahead and look at that speaker bio window right next to that main presentation window. So with that, gentlemen, I'd like to welcome you all to today's event. And I'm going to pass things along to Taylor to get us started. So Taylor, go right ahead.
Katie, thank you for that wonderful introduction. Hi, I'm Taylor. I'm with Raise3D. I'm with the company that has developed the DF2 system, and it's with our DF2 precision and Loctite's innovation, HellermannTyton was able to do an advanced application that I know everyone's excited to hear about that. And Ed will also go into detail about how their process for validating resins for our machine, which is also very interesting. But a little bit about Raise3D before we get to all that. We are an international company. We have offices in Lake Forest, California, and in Houston, Texas. I am currently out of the Houston, Texas office, but we do have European offices and offices in China as well. But as you can see below, we do have resellers, distributors all throughout the world, so we can get our products to wherever you need them to be. A little history about us. We were founded just under 10 years ago when we started off with just FFF printing. And we developed our machines to be highly precision, highly professional, well-built machines. And then after our released machines, we released our own slicer idea maker, which I'll go in a little bit more detail on that later on. But as we have grown as a company with our filament fabrication technology, we're able to go into the resin segment of the market and develop this wonderful DF2 that the HellermannTyton was able to use for their application. So the DF2 resin system is, as you can see, beyond prototyping with traceable workflows from start to finish. I'll go into detail on the traceable workflow here in a second, but a little bit of specs on the machine itself. So the DF2 is a pretty decent sized machine, but I do want to point out this workload with the 12 kilograms. It's able to hold a good dense material and still produce accurate parts each time. So you are able to put a good amount of weight on that build plate that you see here and still have successful prints time and time again. A big question that people have most of the time when it's about resin printing compared to other additive manufacturing processes, one thing I do want to point out is this surface and precision effect that is unrivaled when it comes to resin. You're able to get really high quality prints, smooth prints with great dimensional accuracy. And it's mainly because of the resins that we use. We have our own resins and we also have the open resin program, but I will go into more detail about that a little bit later. One of the key things with resin printing is to kind of keep in mind of the challenges. It can be messy. They are liquid resins, and post-processing solvents require sensitive handling. It is a little labor intensive and requires some technical knowledge and manual operation between the print, the wash station, and the cure station. And also resin printing may result in inconsistent results with, the multiple steps with changing factors, also manual error, and then low print success. We took these challenges on ourselves and we answered it with the DF2 solution. So we have an end-to-end traceable workflow with RFID tracking and automated wash and cure profiles that are automatically generated within our slicing software to make sure you're not overwashing it or over curing the part and you're getting a successful print time and time again. We have advanced optical design and system calibrations and optimizations for greater first print success. And a lot of great software features that are already included where others would probably charge for that. And I'll go into detail about that as well. And then streamlined resin management featuring partial automation on that as well. So the end-to-end workflow on the DF2, you just start off by choosing your resin. You start off with a Raise3D resin or a Loctite resin. We also support other resins out there, like from BASF. You go into the slicer, you plan it out, and then print, wash, and cure. The way that it's able to do this end-to-end workflow is because of our smart build plate with RFID technology that's integrated into the build plate. So all the post-processing settings are already into the RFID. So all you do is after you get it to the printer, you hit print. When the print is done, you move it over to the wash station, scan it, hit play. Then you move it over to the cure station, scan it, hit play. It's a very simple system and makes it very much user-friendly for whoever you want to operate the machine. And as I mentioned before, we do have efficient material management, so automatic resin recognition weighing, again, with the RFID technology. And then also with level detection, so where it will automatically add more resin as needed for the part if need be. And also, we also offer multiple vats with covers, so you don't have to go through that process of pouring it back into the resin bottle, spraying it out with alcohol, wiping it all out. We're making it as simple as possible for you. That's why Ethan was able to have so much success with it. One thing I'm really excited to mention is our Texas Instruments first integrated DMD chip for accurate printing. Our printer does have a 405 nanometer wavelength, just so y'all know, and also with optical glass by Schott, Germany. This type of equipment that we're mentioning right now, you're going to see that in $100,000 machines, $250,000, $500,000 machines, while our entire system is only $8,000, and that's the auto feeder all the way to the cure station. And we were able to get that into our system and print highly accurate parts time and time again, mainly by the genius of our engineers. The air peel technology is actually a really cool little invention that we did. It's what it is we're injecting air between the glass and the FEP film, to help ensure that the part is able to come off the film nice and easy for successful prints time and time again. So that way the part doesn't get stuck to the film, causing some form of suction on there that's not conducive to successful printing. And as you can see here, the Ultra Air Film assists with peeling. Some other manufacturers may tilt the glass to help peel it off there. We have found that may lead to issues with resin falling in there due to just mismanagement, and that is never a fun time to get resin out of the machine itself. The main reason that a lot of successful prints are happening is because our all-in-one slicing process. It generates auto supports, hollow out the model if you need to, add drainage holes, but also has texture generation, suction cup detection, and auto orientation. We even have a one-click print feature where all you have to do is click one-click print. It'll auto-orientate, auto-support, and get everything ready to go, so you can just hit print immediately. I do want to point out that some of these features, like texture generation, suction cup, and some other features in here, are behind paywalls and other slicers. That's not the case here. With the whole system, you get the Idea Maker slicing software and the entire system all in one go. We do have our open resin program, so we have developed our own resins for the machine, which are very good resins. We've also teamed up with Loctite and BASF, as I mentioned before, and worked closely with them to make sure that their resins that they're producing are able to be printed with accuracy each time. A little bit more about our resins right here. We do have, just standard white resin, but we also have high detail apricot, high clear resin, but also tough and rigid resins as well. And here's a little bit of examples on the side over here. Henkel LOCTITE has validated their NID 405 and their Pro 476 on our systems as well. And what that is a full and in-depth process that Loctite does. I wanted to hand it over to Ed to kind of talk about that a little bit more, to kind of talk about that validation process and also what other resins y'all have available.
Yeah, thanks a lot, Taylor. I appreciate the introduction. So I'm Ed Thomas. I'm the North American Business Development Manager, or one of a couple North American Business Development Managers for Loctite 3D printing. I think if you work in kind of a commercial or industrial manufacturing setting right now, you're probably very familiar with Loctite and our really wide array of adhesives for bonding, multiple materials. But we also have a business unit devoted to 3D printing. So we produce high-end photopolymer resins for DLP, digital light projection, so like the Raise3D printer, and LCD style printers. We have a wide array of materials, everything from tough engineering grade polymers to high temperature resistance, low off gassing, flame retardant, ESD, or elastomeric medical materials. And the ones you see in call-out boxes that are red on the screen now are ones that we have completed what we call workflow validation on the Raise DF2 printer, which is why I'm here today. So lots of material companies have pretty broad portfolios of materials that they can offer for their printers, third-party printers, whatever it is. What really sets Loctite 3D printing apart is our material validation process. And what that is a pretty in-depth process we go through for the development of a workflow for a printer. So a workflow is basically everything from the selection of a material, the pouring that into a printer, and then picking all those build settings for that specific printer, how you clean and wash the part, and then how you cure the part so that you will have the final part properties that should replicate what's on the technical data sheet and should meet all the requirements for any certifications that material has, things like cytotoxicity or skin sensitization. This might sound like a really simple kind of process, but when you consider there's usually 60 to 100 parameters that our engineers are kind of adjusting to dial in these print settings, it's a very time-consuming and labor-intensive engineering process, something that we take a lot of pride in working with companies like Raise3D to ensure that when we say there's a workflow for the DF2 printer for, IND 405 or Pro 476, some of our materials, our users, if they follow that workflow, will hit the properties that are on our technical data sheets. These are not kind of aspirational goals. These are things that by following our instructions are very easily achievable. So I also mentioned technical data sheets. This is something that really sets Loctite apart from a lot of our competitors in this industry. Everyone's familiar, every material likely has a technical data sheet that includes things like elongation at break, tensile testing, or heat deflection temperatures. But our TDSs are what I'd consider the gold standard in the industry. Some of them are over 20 or 24 pages long. And aside from containing the standard information that you'd find on any kind of TDS that any engineer might want to use, we also have a lot of more niche data available, everything from accelerated UV aging to water and moisture absorption rates, to chemical compatibility, and we've started to get into things like salt spray testing. Really, the information that engineers need to kind of de-risk a lot of their, initial part production. You don't want to have to go and spend time trying to figure out which of these 20 resins is going to deliver the properties that you want. You know what you're getting with a Loctite resin. And as always, we are an engineering-heavy organization. We're always willing to do additional testing with end users or companies like Raise3D. If there's a business case and there's specific application testing needed, we're always happy to do that as well. So I really think that's what sets kind of Loctite apart and why we're very happy to partner with a company like Raise3D that has built a printer that's incredibly user-friendly to operate, because that really fits well with our desire to share workflows that take a lot of the trial and error out of 3D printing. Talking about two of the resins we have available right now that we have workflows for the DF2 printer. The first one is Pro 476. This is a tough, high-impact resin with relatively stiff, not low elongation, but moderate elongation, and a moderate heat resistance of a heat deflection temperature of about 60 degrees Celsius. And we've seen this for not just jigs and fixtures, but a lot of housings, covers, really any kind of general purpose polymer that you need, really similar to ABS in a thermoplastic, which is one of the most commonly used thermoplastics. Its properties would be very similar to that without being a true thermoplastic material. And then really kind of what wanted to not spend time, but kind of emphasize today is a material like our IND 405 black. This is a very high impact, high elongation resin. It's 100% elongation at break for a rigid material is very, very good. This is a material you could literally make a hammer out of if you wanted to in terms of its impact strength. And it is really suitable as kind of a replacement for things like a polypropylene-like material, where you might want to make living hinges or clips or fasteners, things that are required to go through repeated stresses and returning to their normal shape. This material is a very good proxy for thermoplastics like polypropylene. And this is really what I believe Ethan at HellermannTyton's been using. So I'm going to turn it over to him so he can talk actually about specific applications that he's using with this material.
Thanks for the handoff, Ed. I'm a product development engineer here at HellermannTyton, working primarily in the automotive team here, which I'll change slides for you. So mainly I work with automotive customers in the transportation industry, things like heavy trucks, semi-truck, farm equipment, and so on. Pretty much anything that has a wheels I've probably designed a part for. So a little intro into HellermannTyton. Fairly unknown company to a lot of people outside of our industry, outside of being in the automotive industry or working with wire harnesses. I often describe it as we make really fancy zip ties, things that you wouldn't normally find in the traditional hardware store aisle. So many of the things that we do are cable ties that have these type of fasteners on there, things like fir trees, arrowheads, stud mounts, things that fixate wire harnesses and fluid routing hoses to the vehicle. Fluid routing is one of the industries where we've expanded into a lot, especially with the EV market coming along, is those vehicles have a significantly higher degree of cooling requirements than your traditional internal combustion engine. So yeah, here's kind of a little product portfolio image in those, and then we'll show some of the other type of ratchet clamps and things that we have. But, you know, in the industries we're in, we're typically in automotive companies like such Ford, GM, Rivian, Tesla, Ram, and Jeep. An interesting thing is if you have a Ford F-150 or a Dodge Ram, you could probably pop the hood on that car and you'd find roughly 50 parts that we designed and produced for that vehicle. So pretty heavily used in the automotive industry, but pretty unknown to the average consumer. So our department, what did I do? Oh, crap, sorry, getting confused here. So what I wanted to touch on was kind of how our product development process flows with 3D printing and where we started. We used to start with a small FDM printer, and that gave us some good size and shapes of parts that we printed out of ABS initially. It was an old Stratasys Mojo machine, if some of you remember those. Terrible part performance for us, but at least we had a physical representation of our design to show people. Later, we invested in an SLA machine, and we were able to get more function out of the designs, but it still wasn't good enough to use on an end-use part or send out to our customers to say, hey, try this and see if it works. That led us to outsourcing a lot, which was previously the best way to get quality parts. But it's also very expensive and time-consuming. Time is one of the resources we don't have when we work in the automotive industry, as timelines are very tight and you need quick responses a lot. So our typical path, and you know, we still use it today on a lot of internal development work that doesn't really have a tight timeline, is we'll start in PLA and FFF, and then we'll jump into some SLAs and use those to convey our message to marketing. Then we'll outsource, and then we will go into our production material, which is usually an injection molded PA66 based nylon. So one of the things is, and with the outsourcing, the great thing about the outsourcing is some of these high-end printing machines, which, you know, they can cost hundreds of thousands of dollars. They can cost up to $500,000 for these machines. They give you great parts, but man, are they expensive, and they're hard to bring into a company to use, which is why we were excited about the DF2. The costly and time-consuming nature of that It works, but it sucks. And so for the automotive process, we typically were not able to waste the time in using multiple processes to iterate using cheaper in-house prints. We'd go straight to being confident in the design to jumping straight into the outsourcing. So why does any of this matter? So to us, when we added the DF2 in-house, we were able to bypass all of that kind of nonsense of jumping from process to outsourcing, to getting quotes, testing parts, and waiting for parts to arrive, and able to get a reliable print with a material we trusted kind of on the first print in-house. And that was pretty alarming for us. We don't have to wait for the parts to come. We can get parts for test fits within the same day, sometimes within 2 days, and it's pretty crazy. It's tough to describe to people how beneficial it is to be able to do a same-day print or an overnight print in a new design that behaves exactly the way or similar to what you would expect your injection molded part to be. And to be able to take those designs and send them to a customer and have them give you feedback within the week on what they like, what they don't like, and how it worked and how it didn't work. So that's kind of why we print. Our department is heavily dependent on these machines to get us functional parts in a short amount of time. We're typically receiving new design requests every week. Sometimes it's multiple. Most of the time these designs are requested to be sent back in 4 or 5 days, just to give them samples in 4 or 5 days. It's not even just being able to send designs back. And so being that we work in the automotive industry, it's very fast paced. Typically we're sending these printed models to customers the same week that they asked us to come up with a solution to solve. We're very heavily invested in Ford, and there have been times where the Ford Super Duty plant has called one of our engineers on the phone and said, hey, this part failed, and I'm going to send you the CAD. We need you to come up with a solution this week. And we have to send them something down to the durability test track to get the solution solved. And so most of these part designs are typically done in family designs then as well. So we're not just making one design, we're making one design with 5 to 10 different fixings on the bottom of them. This creates, a lot of time spent on drawings and models and copying and pasting different dimension schemes on different prints, because, we'll go from the same ratchet clamp that's on here has, 4 to 5 different mounting designs or mountings for the bottom, or fixings I should call them. Round fir trees, oval flir trees, slots, stud mounts, and that adds up to a lot of time spent doing the actual design work versus waiting for somebody to print those designs for us. We need to test it quick to be able to jump onto those designs and have confidence in it to finish the work versus waiting for prints to arrive for 5 days. So our DF2 experience, one of the great things and why we really were happy with this is we were able to hit the ground running with it, because the work that Loctite did that Ed described was great. The material validated and the print parameter set up ahead of time was probably the best thing that we've seen in printing for a while. I've even heard from some of the big companies that one of the education departments has a very high-end machine that it took them 6 months to get the thing up and running, really, because they couldn't figure out how to set all the processing parameters correct. This is one of the best features between Loctite and Raise being a partnership is they do a lot of that work for you. So when I get it as the user, I know I can press play and the machine will work out very well. And I won't have to worry about setting up the parameters. Another engineer here does this at home for fun, and he prints figurines for board games. He can sometimes take 5 to 10 prints just to get a processing parameter correct to make sure the part is going to come out and print and stick to the build plate and be successful. And thankfully, Loctite does a lot of that up front for us so that it takes the guesswork out of it. One of the things this machine excelled at right from the start was the part in the upper right-hand corner here. that is an oval fir tree that's meant to retain to a slotted hole in the automotive industry, and they're used all over your vehicle in terms of mounting wire harnesses in place. Those little branches that you see that are little steps, those are a 0.5 millimeter thick. And it's pretty incredible what a 0.5 millimeter thick piece of plastic can do in terms of retention and how it retains inside of a sheet metal hole. But this is a design that we've sent out to various OEMs in the past to, or I should say, printing OEMs, to do stress tests on and see how they could print it and if they could print it in their material. And it's pretty shocking how many companies struggled to make just one of these parts correctly without trialing and erroring 5 to 10 times just to get a part coming off the machine. So we were really surprised when we were able to print this part pretty much the first week we got the machine up and running and set up, and be able to print it successfully. It was really shocking. The I&D 405 material also as well behaved in the same way that our injection molded PA66 nylon did. It's pretty crazy that we were able to get this success on a machine that Raise produced when we struggled for probably 3 to 4 years to find a resin printer that was able to do this. So we were very happy with that. And the 405 material is giving us expected performance values that we can trace back to our injection molded 6.6 based nylon, which is probably one of the hardest materials to copy in the additive industry. Just because of the way it behaves, and it's very flexible for living hinges, but then it's also can be really rigid like an ABS if you design the structure and geometry right. One last little detail here that I have on the screen is circled in the green image, and that's the drain tank for the wash system. So it sounds silly, but this is something we've loved about this wash station and system, is that it has a self-draining feature. So you don't have to worry about tipping the bucket over and pouring it into another bucket when you want to empty it. You can just hit the auto drain button, and it will drain the whole entire resin wash tank into that bucket, and that bucket is bigger than all the IPA that's in there. So we can constantly keep the IPA fresher for longer by using a smaller quantity and constantly draining and replenishing it, which makes it so much easier to use when you're dealing with, alcohol that gets saturated with resin and then no longer washes as well on parts like ours, which in this image, like all these little cavities and things for injection molding that you have are really difficult to get resin cleaned out of them. So by being able to constantly swap the alcohol between these two is very awesome for us. And then the last thing I wanted to touch on was kind of the end-use nature of our parts and how we use them. Almost all the designs we print get tested in some way, whether it is a test fit check or put on a tensile tester and pulled to failure. We don't often design just kind of parts to just look good or look at to say like, hey, this is what it looks like, because somebody is going to test them to make sure they work in some way, shape, or form. We often will print a small quantity, 5 to 10 for our own use, our own testing, and our own engineers to work with, and then we'll repeat that same printing for quantities of 20 to 30 to send out to customers to end up using on durability vehicles and testing. They'll put them on the test track. They'll stress them by putting them on their operators on the assembly line to set up the assembly lines prior to them being molded. They go on to production vehicles to get tested out to see if they're going to work, much like I described trying to solve a problem at a Ford plant. They'll go right on that durability vehicle and they'll go drive it around the test track for hours to determine if that part broke and the other part didn't. So we need to make sure the performance of the material is well enough to handle those details that our customers are putting them through. It kind of depends on what your definition of an end-use part is, but we've probably done it with this combination at least once or twice already. And, we've even put these parts into solar farms, which is a whole nother different element of use cases. So we've done a lot with these, and we have a lot of confidence in the kind of part design that we can produce using Loctite's IND 405 and the DF2. That's all I got to present, so I think it's time to do some Q&A, Katie.
Yes, great. Thank you so much, gentlemen, for the great presentation. So we are going to move into taking some questions from our audience members at this time. All right, gentlemen, I'm just going to grab this first one here that we have from an attendee. This person is asking, is the resin an acrylic?
I can take that one. I'm Ed with Loctite. I know I can't speak on behalf of all of Raise3D's resins, but yes, the Loctite resins are acrylic-based resins.
Thank you so much for that answer. All right, gentlemen, moving to our next one here. All right, this person is asking, what are some common challenges in resin 3D printing, and how does the DF2 address them?
Yeah, I could definitely take that for you, Katie. I did address that earlier in the presentation, but one of the major challenges is basically it being messy with handling liquid resins, potential lack of knowledge on how long to expose layers to the resin, wash the resin because you can overwash it, and or cure it, which you can overcure it. And the way that we've addressed those issues is the workflow management with the RFID integrated smart build plate, to where it just simply passes over the information for the wash time and the cure time to the next machine to just make the workflow nice and easy for everyone. You just slide it over there and you hit play. And then also we do have a good resin management system with RFID coding in there. So that way you can track you can leave the resin within the vat, put a lid on it, and just use a new vat for the next resin and track the usage off of that if you would like.
All right, thank you so much for that answer. All right, gentlemen, looking through the queue here, this next one here, what post-processing steps are involved with resin 3D prints, and how do they affect the final product quality?
I can start off on that one. Like I mentioned in the last question, you know, the post-processing steps is you print the model, then you wash it, and then you cure it. And if you overwash it or overcure it, it could lead to or changes in the model, unintended changes in the model. It could also lead to some type of warping or inflammation is the best way to put it, even though it's not a living thing. So if you don't have the times in place for washing, curing, or if you overexpose within the printer, it could lead to some issues. But the good thing is our slicer handles all of that, and we also offer training on all of our products. So if you are new to resin 3D printing and you're still unsure, we have a full fleet of people here to help with that, with training, with our tech support. And if you ever have any issues with anything, you can always reach out to me, to the tech team or application engineer, anything like that. Ed, what are your takes on like the post-processing steps, and what have you seen?
Yeah, I think you described it pretty well. Obviously, it's if support structures are required, they need to be removed. But if that's done prior to the post-cure, that can be relatively easy. If it's after the post-cure, it might require just quick clipping off. And then, yeah, washing and, the final post-cure in most cases. But again, the Raise3D does a pretty good job of automating most of those steps to make it less time consuming or less of a bottleneck, more automated than a lot of other systems.
All right, great. Thank you for that answer. All right, gentlemen, next one here. How does resin printing enable more complex geometries compared to traditional machining methods?
I'd say I'm happy to take this one if no one else wants it. That's, I think, a big value, not just for resin, but all of 3D printing. If you're doing a traditional machining job, every single cut you do costs money just through time, the use of that machine. Its complexity costs money, where on 3D printing, complexity is typically free. The more detailed that part is, it's irrelevant for a 3D printer. It's going to print at the same time regardless. Whereas machining, each additional cost is prohibitive.
I think I can add to that too a little bit. Is most of our part designs that we have are impossible to produce without long-term investment in molding and cutting the mold using things like EDM burning electrodes and stuff. So most of our molds could give us, they could take 18 weeks to build a tool for some of these parts, and they're very complex and very expensive injection molds to be made. So being able to print that level of complexity in a couple days is pretty remarkable without the need for machining or to do anything other post-processing steps like that.
Gentlemen, thank you both so much for that answer. All right, moving on in our queue here. This next question, resin printing has been historically cost prohibitive for us. How much does this system cost?
Yeah, so the entire system is $8,000. That's the auto filler, the wash or the printer itself, the wash station, and the cure station, as well as the drain collection that Ethan was talking about that made his process so easy. All that, then also what comes with that is access to Idea Maker, access to our lifetime technical support of the machine. Also a 1-year warranty with the machine. We do have extended warranties available. Also training is available. So yeah, with the machine, this whole system itself is $8,000, and it's not just the system. You get a whole fleet of people to support you on that.
All right, thank you so much. And just to kind of follow up on that, there is another question that kind of fits into this topic. What are the features for your wash and cure, and how much does it cost?
What are the features of our wash and cure, and how much does it cost?
Yes, correct.
I'm not sure on the wash station and cure station right off the top of my head. I can actually find that really quickly. But the big features is the auto drainage system for our wash system, is the auto drainage system for the collection, the RFID capabilities, the RFID technology capabilities, and then also you can also just either wash it on the build plate, or there's even a basket in there to place it in there. With the cure station, again, RFID technology capabilities, as well as a fully enclosed cure station with mirrors to make sure that the LED is hitting every aspect of the model, and also a rotating bed on there as well.
All right, thank you so much for that answer. All right, looking at the queue here, gentlemen, we've got time for some more. So we're going to go with, can resin 3D printing be used for end-use parts, or is it primarily for prototyping?
Yeah, I think that I could touch on that. Basically, it depends on what your end-use part requirement is and what the material is capable of. There's certain limitations to a lot of these materials on the market right now, things like UL 747B testing, which is a 3,000-hour heat exposure test, and some automotive specs that I know these materials don't work for, but I can still use them as a end-use part. That would be a printed prototype or a limited production part that has a use in application versus just like a use in a prototype spot. It all depends on what your actual end-use part requirement is from a material side. And these materials continue to get better and better to meet some of these requirements over time. So some of these limitations they currently have will probably get wiped away eventually.
All right, thank you so much for that answer. Looking at the queue here, next one. There are currently 9 resins offered. Is Raise working on getting more resin offerings?
Absolutely. We actually have, we're going to be releasing 7 more resins that are going to be also include Henkel resins, or LOCTITE, excuse me, and BASF, as well as our own brand of resins as well. Again, we do have the open resin program. So if you find a resin that you are liking, that you're needing to use, and it works for the specs of our machine, you can always reach out to our tech support team to help develop settings for that. And again, our tech support is always available during normal business hours to answer any questions that you may have about that.
All right. Thank you so much for that answer. So just a reminder to the audience members, feel free to use that Q&A window to ask any questions that you might have today. All right, gentlemen, next question here. What maintenance and operational considerations should users keep in mind when using the DF2?
That's a very good question. The maintenance on there, we do, again, like I mentioned many times before with our tech support, we do have a support center website that has walkthroughs on all the maintenances. So just because I say it here doesn't mean it's just lost to the ether. You can always go to our website, go to our support center, and it will give you a walkthrough on all the maintenances that you would do. But it would be more of like how to with the printer itself, it's cleaning and storing the resin tank. With the DF wash, it would be making sure that the isopropyl alcohol that's in there is nice and clean. And again, we have the drainage system to help change that out. And then with the cure system, there's not really much maintenance other than maintaining a clean environment outside of that.
Thank you so much for that answer. All right, next question from our audience member here. Did you say you allow customers to print your parts themselves in-house?
No, we don't do that. We would print them in-house and then ship the physical parts out to them. Most of all these designs we are proprietary and stay in-house, and they only receive the physical representation of the part.
All right, thank you so much for that answer. Next one here. How does resin 3D printing support low volume production or customization for specific industries?
I'm going to let Ethan answer that one because he's actually the end user. So I was just wondering, like, if you want to elaborate on that low production volume and customization for your specific industry.
For us, a lot of it is based around the customer needs many different things. You know, I touched on the family parts that we have. Most of the time, a customer will come to us and go, hey, I need you to give me a part that does this diameter here and does this here and fixates this way. Well, our marketing team will take that and say, okay, I'm going to make a family of that part, and they're going to turn it into 8 different parts. And then another customer will somehow come onto that project and add on to the 8th part, onto one of those 8s. So now all of a sudden that part designed for one customer turns into a multiple customer project with different requirements on each one. And so by allowing us to print, we can easily turn around those prototypes and try and add volumes to the sales initially by being able to quickly send out multiple different prints that are different configurations before we've even got started on injection molding. So before steel's even cut, we can gain more customers to that project just by being able to turn around different designs over and over again.
Yeah. And also to kind of add on to other industries like the jewelry industry that needs fine details or prototyping with intricate parts and pieces, that's where the resin 3D printing comes into support, that low volume production and customization for whatever industry you're a part of. Even in the medical industry, duplicating 3D scans of patients, that's possible on specific parts of them, things like that. And I'm sorry, Ethan, I think I cut you off.
Yeah, I was just going to add the beauty of also resin printing is that, you know, you can take that machine that you have, drop in a different material and get a completely different outcome than you have before. The IND 405 works great for us because it matches the performance of the material that we use in millions of pounds per year in injection molded grade PA66 nylon. But, you know, with having that machine, we can swap the build tank out and we can put in a different material like a rigid 3K or tough 2K material from Raise or other Loctite materials. And all of a sudden we now can produce fixtures, we can produce measurement fixtures, we can produce holding fixtures for testing inside an oven, things of that nature that gives you that customization and freedom to do whatever you want with that machine once you have it, because there's probably a material on the market that does what you need it to do. You just have to find that material to put it in your machine.
All right, guys, thank you so much for that answer. We've got time for a couple more questions here. So any audience members, if you have a last minute question, now would be the time to enter it into that window. Gentlemen, next one. What safety precautions should be taken when working with resin materials?
Sorry, I forgot to hit unmute again. Be in a well-ventilated area, something that gets old air out and new air in is always a good idea. Operating with, PPE, with safety glasses, face mask, and gloves. Definitely gloves when handling any sort of resin or uncured resin. Cured resin is safe to the touch, but uncured resin can be somewhat toxic to the skin. So safety glasses, face mask, well-ventilated area if possible, and gloves when handling uncured resin.
All right, thank you for that answer. So looking at our time, we are getting close to the top of the hour. We're going to take one more question today, and then we'll start to wrap the webinar up. So gentlemen, this is a great one to end on. This person is asking, can I get a demo or a sample part? Can I see a sample for a particular resins?
Absolutely. Yeah, we do demos on our printer. We also do sample prints. You can go to our website and request a sample print from our website, or you can reach out to a member of our sales team to get a test print done for you. And we do that all the time. I recommend getting a sample part or a test part out to you and then doing the demo, so that way you can discuss the results of the print and see the accuracies and then better understand how that part was made. But yeah, we do demos and sample parts and test prints for customers all the time.
All right, and thank you so much for that last answer. So looking at the time, we're going to wrap things up right now. I wanted to start by saying a huge thank you to our presenters today for a great presentation and for answering some of our attendees' questions.
Thank you for hosting.
Thank you.
Thank you.
Thank you to the audience members for being part of this webinar event. Take care, and we will speak with all of you soon.